So we'll try to enter this problem. Okay, now here you've got the mass of 4, and then the mass of 1, and then the mass of 2. So the first question is that free body diagram of each block. Okay, now the free body diagram here, it will be, you'll have let's say this is the block M1, and then this will be M2. This will be your M2, and obvious, this will be your M3. Okay, so now here you're going to have a weight which is going to be M1G. And then obvious, here you're going to have a tension. We're going to call this one T1. All right, I'll call this one T1. And then also here you're going to have a weight, because you know that this is the surface, so you'll have a weight which is pulling it down, so it will be M2G, and then from here you'll have a normal force which is sort of opposite, so you'll have a normal force here. Okay, so now here also same thing, you'll have a weight of a M3, and then here you'll have a tension, so you'll have a T3. So mind you, here you've got a friction, right? So because more mass is here on M1, so the system will go this direction. The whole system will try to come this side. This one will go up, this one will go to the right. So now here you'll have a friction which is opposing the motion, right? So the force here, because this is a pulley, the force here and here, so this one will try to be T. This one will also be T1, right? Because here they've got pulley, this force and this force, they're equal. And then if here is T3, I can just say maybe here T2, and then also to say that here, if this force is going up, so it means that this one will also go this direction. So you will have T2 this side. Okay, so now all these are the first, you might do this and this will cancel, right? Okay, and then now you'll agree with me that the tension will be this side, which is T1, and also the tension will be this side, which is T2, going this direction. Okay, now determine the magnitude in the direction of the acceleration of each block. Okay, so now mind you, don't forget that this one is a force. Okay, so now you can work with the second law of Newton. You've got F. I'm struggling to write, but I will push. You've got F net, which is equals to MT, the mass total, applied by acceleration. Right? So when you make the acceleration subject of the formula, you'll have acceleration is equals to F net over empty, right? So now what is your Fnet? So now, so just suppose this system, think of it as a one system. So it means that now you will have consider here at the M1. So now in this case, ignore the tensions, ignore all the tension force. So you'll come and say it will be here M1 G will be M1 G, right? It will be M1 G because this force is going down, and then now also the direction we're choosing direction A as we're choosing downwards as positive, right? It means that the whole system, because here we've got more mass, all this mass will try to move to this direction. So now it will be M1 G, and then now when you get here, because now the friction is also going this side, is opposing, so you say minus, then you minus your friction. You minus your friction, and then also here the weight, it will be pulling down the block, right? And then the block will be wanting to go to the more mass here at M1. So now you will also say minus is in opposite direction, minus M3. Oh, there is G. It will be M3, M3 G all over by. So is the total mass. So now you'll have M1. Okay, you have got M1 plus your M2 plus your M3 is 3. Okay, so still continuing. So now you will have M1G. You know that, guys, here in the friction, the F, right, is equals to coefficient of a friction, okay? Coefficient of a friction, mu, multiplied by N, right? If here, this and this, they're equal, so it means that N now is also equal to this, which is M2. So it will be, the mu will be M2 G, that's normal force, multiplied by coefficient of friction, right? Multiplied by coefficient of friction, like this. So now we're going to have, just substitute this value here, we're going to have M1 G, okay? M1 G minus coefficient of friction here is given here from the above is 0.35. So you will have that mu, which is the coefficient of the friction, and then M2, because it's acting on the block 2. Oh, sorry, M2. I'm struggling with my pen. Okay, let me try to erase this. Now my pen is something else. Okay, so now let's repeat. Here I'm going to have M2 M2G, right? M2G, okay, minus M3G, okay. Suppose this is G, Now, all over by the sum of the mass, which is M1 plus M2. This is our M2 plus M3. Okay, guys. So don't forget to subscribe here on the channel, on the red button there. Okay, now just subscribe for more videos. So now, given that we have to come and substitute our values here. So now let me draw a line here. Okay, now when we substitute M1, this will be equal to M1 is 4. You will have the mass of 4 multiplied by, I'll put dot right for multiplied by G. Okay, or here you can just come and take out the common factor of G, right? Okay, you can take the common factors of G, so you'll have M1 minus mu is 0.35. Okay, minus your M2, your M3 here. Okay, let's say 0.5 multiplied by, here is multiplied by your M2. The mass there is 1, multiplied by 1. Okay, minus your M3, which is 2, right? And then all of this, you multiply it by G, which is 9.8, which is 9.8, right? All over by M1, which is 4, plus M2, which is 1, plus M3, which is 2. So now when you punch all that in a calculator, you should get something like you get 2.31 meter second squared, right? So the direction we chose downward as positive, so it will be downwards, right? It will be downward. It will be down. Oh, sorry. It will be downward. I'm struggling with my pen here. Okay, you'll have a downward direction here. This side is downward. I'll just write down. I'll just write down for now. Okay, so now here it means that the direction is 2.31. All this they will move in the same direction, in the same acceleration. But now, because the acceleration is a vector quantity, you know, you'll have some directions. So this one when it's going down, and then also this one will move to the left, and then also this one will go up, right? So now let's determine the tension in the cords. So now for you to determine the tension, okay, for you to determine the tension, you're going to have, let me erase here. Let me erase here. Okay. So let's go back. for you to have a tension, you can just zoom. You have to zoom in one box, and then that you can get your tension, right? So for example, if we zoom here, so here you've got the tension which is pulling upward, right? So now this tension here, so zoom here, we're looking in this diagram only, right? So now your tension will be, so here you've got mass which is downward and this tension which is upward. Okay, so now you can do the same. You can say F net on the block. You can say F net will be equal to M of 1 A, right? So which are the forces acting on the block? You've got this one and this one. So it means that so your M1 is downward, so you'll say M1. So you'll say M1 G. You'll say M1 G, okay? And then this tension is upward. So minus is opposed in the direction of the acceleration is minus. So which is equals to M1 A. M1 A, right? So now make this A subject to the formula. You can transfer this A to the right hand side, and then you can take this to this other side. So you will end up having your tension. This will give you will end up getting your tension T, right? In this case is T1. In this case is T1, which will be equal to okay, M1 G, okay, M1 G minus this one, minus M1 A, right? So mind you, you can come and take the common factor here of M1 into G minus A. Okay. So what is your M1? Your M1 is 4, right? Into your G is 9.8. 9.8 minus your acceleration of 2.31. Okay, your acceleration is just 2.31. So that when you put it in a calculator, but it's simple. You should get about 29.96. 29.96 Newton, right? Newton is when you are here. Okay, so now this force here, this tension here and this tension, they're equal, but the tension here and the tension here, we should also calculate it, because here you say in the two chords, right? So this tension and here, because here there's a mass of different mass, it will not be equal to this one, right? And also, so now you should do the same. So now we zoom into this block, Are we together? So now when you zoom into that block, you are going to use the very same formula. F net is equal to MA. So which are the force acting here? You're going to have, don't forget that this is your G, please. So you're going to have, your M3. Let's hope your M3. That's the weight. M3, what? G minus T2, right? Minus T2 is equal to what? The mass is M3. Okay. The mass is M3 multiplied by acceleration. So now you do the same. You solve for T2. So when you solve for T2, T2 will be equal to, so you just take this one to the right hand side and then this one to this side. So you are going to have your M3G, isn't it? Minus M3A. So you can come and take out here the common factor of what? M3. You should get M3 is equals to M3 into G minus A. Sorry about this. You know, my pen is giving me some problem today. I don't know what's wrong. Okay. So G minus A is G minus A, right? So what is the mass of M3? It's 2. So you should get 2 into what is G? G is 9.8 minus what is acceleration? We got acceleration. So you'll have 2, comma, sorry, 2, comma, 3, 1. You should get 2, comma, here is 2, comma, 3, 1. Right? So when you put that in a calculator or when you just solve, you know, a simple mathematics, you should get about 24.22 Newton. You know the reason why all this tension they're not the same. So here you've got 29 is bigger because now here you've got the bigger mass. So here you've got the smaller mass. So the tension here must be greater than the tension here. So now we can also prove this. You know, it's possible to prove this because we got our just. So now let me just show you how to prove the acceleration. Right. So now, so these are your answer. You are done. So just want to show you how to prove. You come here. Let me first just maybe can't like erase this. I will leave the answer. Okay. Oh, no. Okay. So now when you just want to prove, if you say Fn, I'll just write Fn here to say that that's F net, right? F net is equal to MA. This is not part of the solution, it's just a proof. So now your acceleration is equals to, maybe we can try to zoom into the middle block here. So when you zoom into the middle block, your A is equals to, so here it will be M2 if we're zooming into the middle block. So now You'll have F net, you'll have F n all over by M what? 2, right? So which is equals to, what is the force acting here? So you've got the tension this side, and also you've got the tension this side, isn't it? So it will be T1 minus T2, right? You can have T1 minus T2. T2 is this one. And remember, you've got a friction here which is in the same direction as the T2. So you must subtract the friction, right? You should subtract the friction all over by M2. So this, your T1, you got it, your T1, you got it as, it was 29.96, it was 29.96 minus your T2 is this one here, minus 24.22 minus the friction is this part here, right? Minus the friction. Let me try to erase also here. So you will have that 0 point, because you can calculate it 0 point. You can just calculate it separately and come and subtract it here. So it was 0.35 multiplied by 1, right? Is the friction here. Just multiply the coefficient and the normal force. Don't forget to multiply by 9.8 here because we took it out. Multiply by 9.8 all over by 1, right? So for you, you should get the very same acceleration here of 2.31, then is proven downward, right? So here it will be meter per second squared. So this is just proving. Okay, so guys, don't forget to subscribe in the channel. Thank you very much. See you soon.